right, good day, ladies and gents. All right, so we're going to be working on the study guide. Now, the study guide goes all the way to page 5. However, please note that our study guide is going to be pages 1 through 3, and pages 4 and 5, even though it says study guide, that's really going to be for test corrections / the test boost. So we'll see if we're going to change the name, but test corrections, test boost, same idea. All right, so let's go ahead and start on page 1. So we're starting on page 1. So on page 1, we're just going to be going through a couple of vocabulary words first. Okay, how do you classify triangles by the angles? Okay, so that would be an acute triangle. That would be a right triangle. And I'm just putting a triangle symbol so I don't have to write out the word. There is a obtuse triangle. And there is an equal angular triangle. Okay, now how do you classify by the sides? That would be equilateral triangle, isosceles triangle, and a scaling triangle. Okay, now please remember that if something is equal angular, it is also equilateral at the same time. So think about if all the angles are equal, then all the sides have to be equal. It's the same thing for isosceles. If 2 angles are equal, then 2 sides have to be equal. All right, so equilateral, isosceles, scaling. If you look at your notes on page 2 of your notes, okay, so here are the ways to remember stuff. So classifying by angles. So if all 3 angles are less than 90, then it's acute. If one of the angles is 90, then it's right. If one of the angles is greater than 90, it's obtuse. Now, equal angular means all 3 angles are equal 60. If all 3 angles are equal, yes, it's acute because 60 is less than 90 degrees, but a better word for that would be equal angular. So an equal angular triangle is acute, but this is the better word. So it's like a square. If all 4 sides are equal, yes, it has 4 sides. It's a rectangle, it's a quadrilateral, all that stuff, right? But if all 4 sides are equal, the better name for that would be a square. So just keep that in mind. All right, so if all 3 sides are equal or all 3 angles are equal, it's equal angular, equilateral, stuff like that. Okay, now classifying by sides. So think along the lines of how many horizontal lines are there. So the letter E has 3 horizontal lines. So if 3 sides are equal, then then it's equilateral. So if 3 sides are equal, then 3 angles are equilateral. Anyway, so the letter I has 2 horizontal lines. So there's 2 sides are equal. And S has no horizontal lines, so 0 sides are equal. So that's a good way just to remember it. Okay, and then there was something else right here, but that's not as important. I mean, maybe if you just keep this next to you at all times, that would be very helpful. All right, so just toss that out. All right, so we have that part of the notes done. Okay, so number 3. So looking at this, use a diagram to classify by the angles and then by the sides. So this first thing that we're going to be doing is classifying by the angles. That'll be the first thing. So it's going to be one of these 4 choices. And the second thing we're going to be doing is classifying by the sides. It's going to be one of these 3 choices. So you just have to keep that in mind. All right, so A, B, E. A, B, E. So it looks like this right here. So we're looking at this triangle right here. Now, if you just focus just on this, we know by the angles, one of these angles is 90 degrees. So that's a right triangle. Because just look at the angle. And what angle helped us make that decision? The letter A. I'm just going to circle that to help you know what I'm focused on. I'm going to zoom in just a little bit. Okay, now what about the sides? Okay, so just look at the picture. Looking at the picture, all 3 sides are going to be different. So this is super long, this is super short, and then we have the hypotenuse, which would be the longest side. So that right there would be scaling because none of the sides are equal. So that's a scaling triangle. All right, let's go off of CDF. CDF. So that's this right here. So focus just on this. By the angles, I'm looking at this angle right here. Now, you see how all three of these angles are equal? So all three sides are equal? So that means that all these angles are equal as well. So all these are 60. And I mean, just looking at this, I can really tell that that's bigger than 90 degrees. But if this is 60, this would be 120 to complete the rainbow of a straight line. So this angle right here would have to be 120. That is obtuse. So one of these angles, so the letter F, helped me make the decision that one of these angles is greater than 180. Sorry, one is greater than 90. So that is an obtuse triangle. And just look at all those sides. All those look very different. So that's scalene. It's a scalene triangle once again. All right, and then DEF. DEF. Okay, that's really easy. See how all three sides are equal? All three sides are equal. All three angles would have to be equal. So it's not only are all three sides are equal, but all three angles are equal. So that would be equal angular and equilateral. So if a triangle is one of these, it's automatically the other one. So if it's equal whatever, it's automatically equal whatever on the other part. So if it's one, then it's the other for that. All right, sweet. And how did we make that decision? All of them, because all three angles were 60. Sweet. All right, let's go down to number 4. Okay, so on number 4, complete the sentence. To classify triangles in the coordinate plane, what do we use? Something versus something. Okay, so let's think about this for a second. When you graph these things, so let's just think about that for a second. When you graphed it, you graphed a triangle, right? Okay, and I wanted you to classify the triangles. Well, what did we do every single time? Oh, we made little right triangles, didn't we? We have this one, we have this one, and then we had this one, whatever. Okay, it's a very bad picture, but you know what I'm trying to say. Okay, and then what did we do? Oh, we did a squared plus b squared equals c squared. What's the better name for that? That is the Pythagorean theorem. So Pythagorean theorem. Or another thing we did, we were really just finding the distance. So the distance formula. So the basic thing that we were trying to point out is just for you to be mindful. So as long as you knew that what you were doing was a squared plus p plus b squared equals c squared, that's all that matters. That's the whole point of this question, knowing that you were using a squared plus b squared equals c squared. And the distance formula basically is that a squared plus b squared equals c squared. So just pointing that out. Okay, let's look at this. Now 5 and 6, very important. So it's going to graph it, but I don't have any graph paper on here, do I? Okay, well, let's remedy that, shall we? So let's remedy that on one of these pages. 1, 2, 3, 4, 5. I know there's graphs somewhere. Okay, so if you go to page 3, here's graphs. Very crappy graphs, but they exist. So we're going to use that. So sorry about that. So I have 4 different graphs rocking here. So I gave you 4 very crappy drawings, but we're just going to use that. Okay. So so we have -2, -1. That right there is my Q. 1, positive 5, 1, 2, 3, 4, 5. It's my R. And -8, -4. That's my T. Okay, and then I have my straight edge connecting the dots. Okay, so using that right there. All right. Okay, so just keeping this in mind. Okay, so when we're doing Q to R, so Q to R, I'm making a right triangle. Okay, now how many hops was it? Okay, so going this way, that is 1, 2, 3 hops. So that was 3 hops. Plus, how many hops up did you go? 1, 2, 3, 4, 5, 6 hops. So plus 6 squared. Okay, so we're using that is equal to x squared, right? 3 squared is 9. 6 squared is 36 equals x squared. You add those together, we get 45. Square root both sides, you get the square root of 45. Okay, so now we don't care about making that pretty right now. Just leave it a square root of 45. It doesn't hurt anything. It's okay, because all we're going to be asking is what type of triangle it is. So that's all we really care about at this moment. Okay, so we have the square root of 45. All right, now let's do the same thing to the others. Okay, so q to t. All right, so I'm making a right triangle out of this. All right, so count your hops. Okay, so along the x, we have, so q to t, we have 8 to 2. So that's 1, 2, 3, 4, 5, 6. That's 6 squared plus, and then going up, that's 1, 2, 3. So 3 squared equals x squared. I would get 45 again, so that's a square root of 45. Okay, I ran out of room, so I'll put it up here. Okay, so the other one I'm going to do is RT. So we're making RT, making a right triangle out of this. Okay, so R to T, when you count your hops, we would get 9 hops by 9 hops. So 9 squared plus 9 squared, get 81 plus 81, which is square root of 162. Okay, so at this moment, we have 45, 45, and 162. So square root of each one of those. Okay, so now they said to classify by the sides. So looking at your choices, to classify by the sides, we want to know how many sides are equal. So if we have square root of 45, square root of 45, and square root of 162, how many sides are equal? Only 2. So that would be isosceles. That's an isosceles triangle. And notice that we didn't bother simplifying this. They didn't ask us to, so why do it? So isosceles was our answer. So that's an isosceles triangle. Okay, let's go to number 6. So I'm going to be using this graph. Now, why do you think I gave you 4? Just in case you messed up. So let's go to number 6. So we're on number 6. We're going to do the same thing that we just did a second ago. All right, so let's go ahead and plot the points. We have -2, +5. That's your A. We have 3, -3. That's your B. And we have -4, -1. That is your C. Okay, I'm going to take my straight edge, connect all the dots. Okay, so there's our triangle. So we are going to just focus on one at a time. So let's do A to B, making a right triangle out of that. Just shade it in. All right, so A to B. When you count your hops, okay, we have, so that's 2 hops and then 3 hops. That's 5. So that's 5 hops right there. So 5 squared. And then going down, we have, that's 5 hops and 3 hops together. That makes 8. So plus 8 squared. Okay, so we have 25 plus 64. When you add those together, so 25 plus 64, we get 89. So it's 89. So that's a square root of 89. So A to B is square root of 89. All right, let's do A to C. So A to C, that's, okay, so going this way, that is 1, 2 hops. So it's 2 hops, so 2 squared. So it's A to C. 2 squared plus, going down, that would be 5 hops, then 1 hop, so that's 6 together. Yep, so plus 6 squared. All right, so we get 4 plus 36, which is 40. So we get the square root of 40. I ran out of room, so I'll put it up here. Okay, let's do B to C. So let's go ahead and connect those. All right, so B to C, we have, that would be 3 hops and 4 hops. That's 7 together, so 7 squared. So you can just count your hops. I'm just using math just to help me out, make sure I'm getting the right numbers. And then we had 3 to 1, so that's 2 hops, so plus 2, yep, squared. Okay, so we have 49 plus 4, which is 53. All right, square rooted. Okay, now they said classify by the angles. Okay, I know by the sides, all 3 sides were different. Oh, those tricky little buggers. Okay, so they said classify by the sides. It's going to be one of these. Well, crap. They said to classify by the angles. So it's going to be this. Now, we don't know what the angles are, but there's a way to use the sides and classify by the angles. All right, so very tricky. All right, so how does c squared compare to a squared plus b squared? That's what we're doing. All right, so the biggest side is c. So what was the biggest one? That would be right here. So if I said, in order, we had square root of 40, square root of 53, and the square root of 89. So this would be my A, my B, my C. Or let's do that lowercase. Okay, so we know that we want to know how does C squared compare to A squared plus B squared. That's what we're trying to figure out. So I'll zoom in a little bit. Okay, so we're gonna plug stuff in. Sorry, I ran out of room a little bit. Let me refocus that. Okay, so the square root of 89 squared, how does that compare to the square root of 40 squared plus the square root of 53 squared? Okay, the square root and the square cross each other out, so how does 89 compare to 40 plus 53? So how does 89 compare to, what's 40 plus 53? 93. Okay, and this, we would point at the little number, we eat the bigger number. So, and how would you read that? That's less than, so that would be an acute triangle. Acute. All right, so recap. Okay, so they gave us coordinates. We can find all the side lengths, right? Okay, so we found all the side lengths, and then we know for a fact that no matter what, that this was definitely not a equilateral triangle. I know that for a fact because all the sides were different, right? So they said classify by the angles. So it's definitely not an equal angular triangle because not all 3 were equal. If all 3 sides are not equal, all 3 angles are not equal. And it's between acute, right, and obtuse. And just looking at that picture, that's a little hard to figure out. So so we're going to use how does c squared compare to a squared plus b squared equals c squared. You plugged the stuff in, and you made that decision. Okay, hopefully you guys are okay with that. just practice. Just roll with it. All right, so number 7. My favorite ones. Okay, you guys keep messing up on this. It's really easy. You just have to follow the steps. Don't skip. There are 3 steps to this. 3. Only 3. For whatever reason, you keep stopping at step 2. And what are the steps? You write, so you put the numbers in order. You write down what letters you have, and then what letters you're missing. That's it. That is it. So those are the 3 steps. You might have to do a previous step of finding what the missing number is, but that's about it. All right, so let's actually get this done. So everyone should get 100 on these types of questions. Okay, so I'm going to zoom in on number 7. Here we go. So they said from smallest to largest. Okay, put the numbers from smallest to largest. That's step 1. So smallest to largest would be 10, 20, and 22. It's pretty simple so far, right? Now, what letters do you have? Okay, 10 went with HI. 20 went with IG, and 22 went with GH. And for whatever reason, you guys stop right there. But that's crazy because you haven't answered the question yet. They said, what are the angles? You've given me the side so far. Keep going. Now, what letter or letters are you missing? At this moment, I have HI. What's missing? G. At this moment, I have IG. What's missing? H. And I have GH. What's missing? I. Okay, and so let's put them in order. So they said from smallest to largest, that would be G, H, and I. Now, what's going to happen on the test? They're going to give you the 3 letters. So they're going to go like O, H, G, I, like whatever. And you're going to have to drag over the words. So you're going to have to drag over the word the shortest. So what was the shortest? G. So you're going to have to drag over the word that says the shortest. Okay, and then H is the middle, so you're going to have to drag over the word middle. And then I is the longest, so you're going to have to drag over the word longest or largest, whatever they're talking about. So they're going to put these letters in whatever order they want, and you're just going to have to drag over the correct word. Okay, just pointing that out. Okay, so let's try number 8. Okay, so just go in the same thing. All right, they said from largest to smallest. Okay, just do that. Okay, so largest to smallest. So largest is 24, and then we have 20, and then we have 15. Okay, so that's the order right there, right? Okay, and then 24 went with EF, 20 went with FD, and then 15 went with DE. So we did the numbers, and then what did we have? Okay, so last thing you have to do is the missing. So what's missing? If I have EF, D's missing. FD, E's missing. DE, what's missing? It is the letter F. Okay, so all you have to do now is drag the words over. In this case, this was the largest because the 24 was the largest, so this is the largest. Okay, E is the middle, and 15, that's the smallest. So you're just gonna have to drag over those words, just putting that out there for you, okay? But this was our answer right here, so D, E, and F, pointing that out. All right, let's go to the next page. Okay, so it's still the same page, we're just on the other side. Let's keep going. Okay, so list it from shortest to longest. Okay, so these little buggers, they've only given me 2 angles. Well, how the freak are we supposed to find the other angle? All right, so how do we do that? Well, I have 2 angles at this moment, right? I know that the 3 angles of a triangle, so if this is 70 and this is 65, what's that missing angle? That missing angle, I know that 70, 65, and X add up to 180. So 70 and 65, when I subtract that, X would equal 45. So I subtracted 70, I subtracted 65, I'm left with 45 right there. Okay, so with that little bubble thought out of the way, I know that angle C is equal to 45. So I went out and found that. Okay, so now let's actually do it. So shortest to longest. Shortest to longest. So this was our pre-step. Step 1, write down the numbers in order. So 45, 65, 70. Step 2, what do you have? 45 went with C, 65 went with B, 70 went with A. And now what's missing? If you have C, B, A is missing, or AB, doesn't matter. CA is missing, and BC is missing. Or CB, same thing. So let's just put them in order. Okay, and all you have to do is, on the test, you're just going to be dragging over short, middle, long, over to those whatever letters. Just putting that out there. Okay, number 10, same idea. All right, they just gave you words. Okay, so we know that X, Y, Z, right? So we have X, Y, and Z. Okay, Z was 52. Y was a right angle. So how many degrees is a right angle? Oh, 90. And we just have to figure out what our missing angle is. So we know, well, perfectly enough, X plus 90 plus 52 equals 180. So what is missing? So subtract that, and we get X is equal to 38. So 38 is our missing angle. Awesome. All right, they said from shortest to longest. So that would be 38, 52, 90. So step 1, so we had to do a little pre-step, right? So this is our pre-step. So step 1 is put the numbers in order. Step 2, what do we have? Well, 38 was X, 52 was Z, and 90 was Y. And your last step is what are you missing? Okay, if I have x, y, z is missing. If I have z, x, y is missing. And if I have y, x, z is missing. And that right there is our answer. And just remember, on the test, you're just going to be dragging over the words short, middle, long, stuff like that. Okay. And just be aware that they might mix those up, so you might have to put them in weird spots. Okay, number 11 and 12. I love these ones. Okay, so if you guys look at your notes, because all of this is on your notes. Remember, this was a big freaking no. That was a typo earlier when I was giving you guys the notes. Now, looky here. You are going to take the two numbers. You're going to subtract them, and you're going to add them. When you subtract them, you always pop out as positive. You always give me the positive version of this, okay? All right, so we have two numbers. The two sides are 11 and 8. Okay, subtract 11 and 8. So I'll just show a little extra work. So absolute value of 11 minus 8 is less than x, which is less than 11 plus 8. Didn't matter which order you did. It could be 8 and 11 or 11 and 8. Just as long as you give me the positive version. What's 11 minus 8? You get 3. And what's 11 plus 8? 19. And that right there is your range. Okay, over here. If what is the third side? If the third side is x, the two sides are 14 and 20. These little buggers gave us words instead of the actual numbers. No big deal. So 14 and 20. All right, so subtract the two numbers. So 14 minus 20 is less than x, which is less than 14 plus 20. All right, 14 minus 20 is a negative 6, but we're doing the absolute value of that. And then 14 plus 20 is 34. So a negative 6 absolute value would just be a positive 6 and a 34. So just remember that you're always popping out with the positive numbers. So just be mindful of that. Okay, so number 13. Man, I love this unit. This is great. Okay, D to E. So I'm going to put this in black or blue, whatever. D to E is 5x plus 2. And we have D to F, that's here, is 2x plus 3. And E to F is 3x. Okay, and they said the perimeter of ABC. Okay, so we have the perimeter of the small, and we have the perimeter of the big. So I just write that there. Boom, 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 boom. Okay, so perimeter of the small and the perimeter of the big. Now, the perimeter of the small, what letters are those? That's D, E, and F. What's the perimeter of the big? That would be this big one. That's A, B, and C. Okay, now they said the perimeter of ABC. Now, which one said ABC? Oh, that's the big one. Okay, sweet. Was 50. Okay, so if our big perimeter was 50, what is our small one? You just divide by 2, and that would be 25. So now that we have this idea, so you always find the perimeter of the big and the small. Once you have one, you have the other. Just have to make sure you keep it in order, keep the right one in the right spot. Okay, we have all these things right here. Now, here's the thing. I know I'm going to add all those up. Now, half of you guys are going to go, oh, these add up to 180. No, these do not add up to 180. These are not angles. These are sides. So 5x plus 2 plus 2x plus 3 plus 3x does not equal 180. No, 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 no. 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 Not angles. Okay? Just pointing that out. Okay, what these really do equal, let's write it over again, because notes are good. Okay, what does this equal? What are these? That is the perimeter of the big or the small? The small. So that equals 25. That's what it does. It does not equal 180. It equals 25. This is side lengths, not angles. Okay, 5x, 2x, and 3x, when you put those together, let's double check. So 5, 2, and 3, we get 10. So that's 10x. A positive 2, a positive 3, and nothing. So positive 2, positive 3, we get a 5. So plus 5 equals 25. So 10x, subtract 5 on both sides, we get 20. Divide by 10, x equals 2. Okay, now what have I trained you to do after you find x every time? I've taught you to plug it back in. Put it back in the picture for a number of reasons. For one, it will check yourself. But two, it will also help you to answer any question that they ask. So 5 times 2 plus 2. When I plug it in here, this will disappear, and now this will be a 12. Okay, 2 times 2 plus 3. This would disappear, and now that would be a 7. 3 times 2. This would disappear, and now this would be a 6. Okay, now here's the awesome thing. If this is 12, what's parallel to that? So see this line? This is parallel. So I just slide it. So if this is 12, this would be double that. So all of this would be 24. And this little part would be 12, and that little part would be 12. So see how it's parallel? That's 12, 12, 12, 24. Okay, over here. See that's 6? This over here would be 12. So this, you just double it. So if this is 6, all of this would be 12. And this is 6, and this is 6. Okay, and over here, if this is 7, what's parallel to that? This. So all of this would be 14. And this would be 7, and that would be a 7. Now we're prepared for every question that they ask. They said, hey, what's A to C? Here's A, here's C. What's that whole distance? That would be 12. They said C to B. All this distance would be 14. And what's A to B? All that distance would be 24. And I could also go an extra step and go, what's the perimeter of E? So perimeter of EBF. If I ask you that, you would just go, oh, that's 7 plus 6 plus 12. And you would get 25. Or I could say, hey, what's the perimeter of the quadrilateral DEFA? So I could ask you this weird question. So you would do 6 plus 12 plus 6 plus 12 kind of thing. So I'm just pointing that out. So you're just prepared for every question. All right, let's keep going. Okay, number 14. Okay, so triangle angle sum theorem. Okay, so this is just notes again. So that says, so if you have a triangle, and this is angle A, B, and C, triangle angle sum theorem is A plus B plus C would equal 180. So the three angles of a triangle add up to 180. And what's the exterior angle theorem? Okay, so if this is A, B, and C, basically I would just say A plus B would equal the outside of C. So C was on the inside, it would be the outside. It would be this angle right here. So that's just one way of how to put it. Some other people like to put it this way, where if this is A, this is B, this is C, and now here's D, A plus B equals D. But I think this one makes more sense to you guys. Just point that out. Okay, let's go to the back of that page. Okay, so we're going to page 2. We're going to page 2. We are now on number 16. All right, let's keep going. All right, so these three angles. Okay, so we know the three angles of a triangle add up to 180 degrees. Okay, so we have 8x minus 35 plus 6x minus 5 plus 3x minus 1, all that equals 180. All right, so we have 8 plus 6 plus 3. We get 17x, negative 35, a negative 5, and a negative 1. Those right there add up to a negative 41 equals 180. Okay, so we're going to add 41 to both sides. And we get 17x equals 221. Divide by 17. Get x equals 13. Now, what did I train you always to do? Plug it back into the picture for a number of reasons. One, to check your work, but also to prepare yourself for any question they ask. So when you plug that back in, 8 times 13 minus 35, that'd be 69. 6 times 13 minus 5, this would be 73. 3 times 13 minus 1, that'd be 38. Now, if you add all those together, 69, 73, and 38, Yes, that adds up to 180. I feel really good about that. Now answer their question. Oh, they just wanted x. The answer was 13. But if they asked us for an individual angle, we would have been all set. Okay, which does happen, just point that out. Okay, so over here, okay, we know that the two insides equal the one the outside of the other, right? So 2x plus 20 plus 5x minus 11 equals the outside of the third one, 11x minus 63. All right, 2x and 5x make a 7x. 20 and a negative 11 make 9 equals 11x minus 63. Okay, I'm going to subtract 7x from both sides, or we can go the other way, whatever you like. So 11 minus 7, we get 4x minus 63 equals 9. Add 63 to both sides. 72 is equal to 4x. Divide by 4, x equals 18. Okay, so we're going to plug that into all the pictures. So into the picture here. So let's just to check. So 5 times 18 minus 11, this would be 79. 2 times 18 plus 20, this would be 56. Over here, 11 times 18 minus 63, this would be 135. Now let's go the extra step. If this is 135, then so this makes a rainbow of a straight line. So if this is 135, this would have to be 45 to complete the 180. Now, do these three angles still add up to 180? So 79, 56, and a 45? Yes, those add up to 180, so I'm all set. So if they ask me for one of these individual of the 4 angles, I'd be prepared. They just wanted x. I know I did this right. The answer is 18. All right, let's keep rolling. Okay, these two are the same thing. So those two right there are the same thing. I will be checking for your work on that one. I'll just go ahead and give you the answers. That would be 15, and that would be 11. Please know that I will be checking to make sure that you guys actually did that correctly. So I am looking for the work for that one. So do the work. Set the equation, solve for x. I want to make sure that you know how to do those. And I want to see the angles plugged in. So I want to see you to solve for x, and I want to see you guys plug this in and find all those angles. So 18, 19, I'm going to be checking very closely for those two. Okay, 20 and 21. Okay, so this right here is on the test. It's going to be funky weird, so just bear with me. Okay. So you're going to have to do this with me. Make sure you're paying attention. You might want to watch this part of the video twice. Okay, so 120. Now, I know if this is 120, a rainbow of a straight line makes 180 degrees. So if this is 120, what's this? That right there would be 60. Okay, excellent. Now, do you see this right here? This is an isosceles triangle. See how two sides are equal? So let's rotate our paper until our elbows are on the table. So here are my two arms that are equal, and here are my elbows. So if my two arms are equal, my two elbows are equal. Now, if this is 60, what's left over? So I know that these two are the same. And I'm not going to call it x because x is already being used somewhere else. It's very dangerous. So I'm going to call them y. So I know that both of these are y, right? So I know that 60 plus y equals 180. That's 2y. I'm just showing some work. If you can go like, oh, what's left over is 120, so what's left over? That'd be 60 and 60. Oh my God, they just happen to be the same. You would still get the same answer mathematically. So you get 2y is equal to 120, divide by 2, y is equal to 60. They just happen to be the same number as this one right here. Okay, so we have, just turn this facing up this time. So we have 60, 60, 60. So, hey, look, that's an equilateral triangle. Okay, so all three sides just happen to be the same. All three angles just happen to be equal. All right, so if this is 60, we can do a rainbow of a straight line and say this is 120, or I can go, oh, that's vertical, so this is 60. Or 120, 120. You do you, whatever works for you. Anyway, all right. Oh, look, we have an isosceles triangle again. So let's put our elbows on the table. All right, if this elbow is 60, then my other elbow has to be 60. Man, we're just getting equilateral triangles everywhere. If we have 60 and 60, what's left over is another 60. Okay, so if this is 60, down here would be 60. Man, if this was anything but 120, we would have had a totally different problem going on. Okay, so that was our answer. You just keep moving closer and closer to this until you get there. All right, so let's try this again. 21. Okay, so we have 65. Now, you see how you have these two are equal? So I'm going to turn my paper until my elbows are on the table. So here are my two arms, and here are my elbows. So if this is 65, my other elbow is also 65. So this is also 65. So my two elbows are the same. If this is 65 and 65, what's left over? So 65, 65, and that missing dot equals 180. All right? So 180 minus 65 and 65, I would have 50 degrees left over right there. Okay, so now that that's 50, okay, these would be equal to each other, right? So this is 50. Or if you wanted to travel out here, this would be 130, this would be 130, because it makes a rainbow of a straight line, right? Okay, so if this is 50, oh, look, we have equal sides again. Okay, so let's turn our paper until our elbows are on the table. So here are arms, here are elbows. So if this is 50, my other elbow is also 50. So if this is 50, this is also 50. Okay, if this is 50 and 50, what's left over? So x, 50, and 50 make 180. What would x be equal to? That's 100, that'd be 80. So this right here would be 80. And there you go. Okay, so just fake it till you make it, you'll be just fine. Okay, we're getting closer to being done with this. All right, so let's go over to the other side of this page. Okay, we're on 22. We are on 22. Okay, yes, fun stuff. Okay, write the 3 valid congruent statements for this. Okay, so best way you can do this is write all the letters. So Q is a single angle, P is a double angle, and R is a triple angle. So 1, there's 2, and then there's 3. Okay, so that would match up to, on the other triangle, which one had a single? T. So Q had a single and T had a single, so they are equal to each other. P had a double, U also has a double. And R was a triple. Where's the triple over here? S. So we just need to be mindful that every time we talk about this triangle, we're talking about these letters over here on this triangle. So if I go Q, P, R, that would be T, U, S. So triangle. Make sure that when it says triangle, you're also saying triangle on the other side. So T, U, S. Now if I say triangle, P, Q, R. So I go P, Q, R. P matched up with U, Q matches up with T, and R matches up with S. Okay, and then what if I said triangle? So triangle. If I said R, P, Q. So R matches up with S, P matches up with U, and Q matches up with T. Should definitely get 100 on that part. There's a lot of hundreds floating around here, aren't there? All right, let's keep going. Okay, so 23. Okay, so 23. So before you start, I would just go ahead and write down the letters like I did over here. That helps you just stay organized. So KPL is going to match with ACM. So just keep that in mind when you're matching everything up. Okay, so this is talking about side, so I'm going to be talking about the side over here too. K matches up with A, and L matches up with M. Okay, so we're talking about angle, so we're going to be talking about an angle. P matches up with C. All right, we're talking about a line again. So PL, that would match up. So P matches up with C, and L matches up with M. If you gave me MC, it will be wrong. Okay, so you have to make sure the letters are in the same spots. Okay, and then angle, so I'm going to be talking about angle. M would match up with angle L. Simple as that. All right, let's keep going. All right, so same thing here. Just look at the statement. So before you start, I would just off to the side, WXY matches up with HJI. So just keep that in mind right there. All right, so if I say JI, so JI, so J matches up with X, I matches up with Y. Okay, JHXW. Measurement of angle. Wait a minute. Look, they gave us numbers, didn't they? They gave us numbers. So we're going to have to do numbers. These little tricky buggers. Okay, so let's go back. So I'm going to get out my whiteout. So the fact that they said measurement told me that we're going to be looking for numbers. So that was my little tip off of going, wait a minute, something's wrong. Okay, so let's draw the triangles. So I'm going to draw 2 triangles. Now they said WXY, so WXY, and in the same position, I'm going to write HJI. Okay, and I'm just going to put all this information over here. So W to X, where's W, where's X? Okay, so W to X will be 15. X, which is up here, is 114, and X to Y is 16. Now notice how it's on the bottom here. It's not on the bottom over here, so just be careful with that, okay? And letter H is 37. Now take all this information, copy paste. Take all that information, copy paste. So if this is 114, this is 114. This is 15, 15, 16, 16. Let's see, and 37, 37. All right, are we missing anything? Okay, so if this is 114 and 37, I can find this missing angle. So 180, subtracting the 114 and the 37, I would get 29 left over. I'll do that in pencil. So this is 29, and this is 29. Okay, and then if this is 15 and this is 16, what's left over? We don't know. We could find the range of this, but we just don't know, okay? Unless it was a 90-degree angle, which we don't have. We just don't know what this is. Okay, so now we should be able to answer all the questions. Here we go. J to I. Here's J, here's I, that's 16. Okay, and then J to H, that's 15. Angle W is 37. Angle J is 114. And angle I is 29. We were able to find all those answers. Awesome. Okay, what are the ways to prove triangles are congruent? Okay, now I know the bad ones. The 2 bad ones are ass and ass backwards. And your ass is so big it's triple ass, right? Those are the 2 bad ones, along with order and not enough info, right? Okay, now every other combination of A and S is good, such as side, 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 angle, side, angle. SAA or AAS, that's another one. Means it's AAS, right? Okay, and the only time you're allowed to have an ass is when you have a leg, hypotenuse leg. Okay, and I put a little ass right there. Little ass. Dun, dun, dun. Okay, so hypotenuse leg. All right, so when we travel around these triangles, okay, what do you have the most of? Angles or sides? I have the most angles. So I'm going to go to the third angle I don't have. Now go in a circle, and I would get angle 1, side 1, angle 2. And do the same thing here because the order might be messed up. So if I go in a circle, I get angle 2, side 1, angle 1. Now, does this match exactly? No, it doesn't. Okay, so you have one more backup. What if you just flip one around? Angle 1, side 1, angle 2. Now do they match? Yes. So this is good, ASA. Okay, what about this one? Okay, I only have 2 bits of information. I need something else. That would be reflexive. 1, 2, 3. So that's a reflex property. All right, now be careful. Just because they all have 3 equal sides does not mean anything. Because one side can be a double, double, and triple, and then it could be a single, single, and then triple. That would totally mess you up. All right, so I have a single, double, triple. I have a single, double, triple. That's okay. So that would be side, side, side. Because both of these are single, double, triple, single, double, triple. That is okay. Okay, this one. I only have 2 bits of information. Ooh, I have vertical. There's a third bit. What do you have more of, angles or sides? Sides. Go to the third side you don't have. Go in a circle. I get side 1, side 2, angle 1. Over here, what do you have the most of, angles or sides? Go to the third side. I get side 1, side 2, angle 1. Do these match? Oh, cool, they do. Is SSA good or bad? That's bad. No, that is bad. Why? Because that's ass backwards. So that's a no, so not congruent. Okay, and over here, and then remember, the only time you can have an ass is if you have a leg, if it's a right angle. So if it's a right triangle, then it's all right. Okay, so here we go. So on this one, what do we have more of, angles or sides? Sides, go to the third side, go in a circle, we get angle 90, side 2, side 1, over here, go in a circle, I get angle 90, side 1, side 2. Okay, those match completely. So, oh, that's ass. That's bad. The only time you can have an ass is if you have a leg. Oh, that's hypotenuse leg. It has a right angle, so it's all right. So that's yes, hypotenuse leg. So that's okay. All right, let's keep going. Okay, this is on the test. Please be mindful of this. This is on, well, actually, all this is on the test, but this one you guys do not recognize. We hadn't had practice with this one. Okay, so here we go. So on this one, okay, at this moment, we only have side and side. Now, what am I missing in order to be side, side, side? Okay, so on this triangle, for this to be SSS, so at this moment, I have two sides down. I need a third side. Okay, to make this a third side, so what I'm going to do is I'm going to make this triangle down here. Hold on. Just to keep this organized, A, B, C, X, C, D, double, double, single. Okay, so in order for this to work, I'm missing this side right here and this side right here. So that right there would have to be a triple. So that's what I'm missing. So I would have to have BX is equal to, so I need a side equal to side. That's what I'm missing. So right off the bat, these angles are definitely a no. So they say, oh, look at that. Both of them say BX. So BX would equal, oh, is it XC or CX? All right, so I know, so BX, see how it's on the single side and it's going towards the double side? So do the same thing here. From single side to double side, so that's CX. So this is the better answer, those tricky little buggers. All right, let's do this again. I'm just going to draw the triangle one more time, or the triangles. A, B, X, C, and D. We're a single, double, double, single. Okay, so I need SAS. Now I have, so before I had side and side, I was missing a side. At this moment, I have side and side, I'm missing an angle. So the angle has to be between the two sides. So where's the angle that's right between the two sides? That would be right here. Between the two sides, right here. So I need A to be equal to D. So I need angle equal to angle. So right off the bat, I needed angles be equal, right? So I need A to be in the middle and D to be in the middle. Okay, so A is equal to D, that works. This one says B is equal to C. So that's no freaking way, so it's B. All right, okay. All right, so longest lesson ever. All right, okay, we are on page 3. We are on page 3. Lots of notes. Page 3. Okay, so we're on number 30. Okay, this will go by pretty fast. Okay, so there is an answer bank, which is awesome. You got to label as you go, guys. All right, so they said if, so it is given that Q is the midpoint of P to T and R to S. All right, so boom, that's there. So we're going to be saying these two things, right? So that's a block. So we need to say Q is in the middle of P to T. So here's P to T, and Q is, so this got cut in half. So if that got cut in half, we're going to be saying that this is equal to this. So by blank, PQ, okay, good, PQ be equal to what? Is it QT? So we know for a fact that PQ is either going to be equal to QT or PQ is going to be equal to TQ. One of these is going to be a better choice. Now, if they don't give you the choice, you're okay. So QT and TQ, these freaking buggers, which one do you think it's going to be? Now look at here. This is what we're trying to do. So when I say PQ, that would match up with TQ. So let that help you out. So that'd be TQ would be our better choice. So TQ. Now, why did you know that? What was said for that to happen? What word was said for that to happen? The word midpoint. So by the definition, sorry, not that. So by the definition of midpoint, we know that PQ is equal to TQ and, okay, now RQ. So we did this one. Now RS got cut in half. So I know double is equal to double. So this and this are equal. So if I say RS, so RQ. So RQ would match up with SQ. So notice I'm just using this to help me out. Okay, so don't reinvent the wheel. So SQ would have been our answer. So notice that we have SQ and QS, those tricky little buggers. So SQ would have been the better choice. Okay, then we're going the next step and saying Q is equal to Q. All right, so, okay, Q is equal to Q. Now, why is that? Why is this equal to that? That's vertical, which is right there. Okay, and then finally, why are these two triangles equal? So the only way to prove triangles are equal, the only way are these right here. If you put anything else, you can smack yourself in the back of the head. These are the only ways to prove triangles are equal. That's it. So which rule did you use? All right, so what do you have more of, angles or sides? Side, so go to the third side, go in a circle, you get side, angle, side. Side, angle, side. Right there. Okay, be careful. A lot of people put ASA because they're not paying attention. All right, let's go to number 31. All right, so, and this is how you labeled the triangle. That's all I want to see. Okay, 31, label as you go. Okay, here's the answer bank. Let's just put stuff in there. Okay, AC bisects this angle and this angle. All right, so given that AC bisects angle BAD and angle BCD. Don't reinvent the wheel, just plug stuff in. So I'm just dragging those things in there. So AC, angle BAD, and BCD, boom. Make sure that you're doing the angles and not the triangle thing. Okay, so we know that angle A got cut in half and angle C got cut in half. So angle A, so this angle be equal to this angle, and angle C got cut in half. This angle be equal to this angle. Okay, so BAC would equal DAC. Look, angle A would be equal to angle A. So you just look for the one that has an A in the middle. So we're looking for angles, and with an A in the middle, it's like, oh wait, these little tricky little buggers. Is it DAC or is it DAB? So if I said BAC, that would be DAC. DAC, right there. And then this one we're looking for C in the middle. So let's see, where's an angle where C's in the middle? There's only one other angle, and that's right here, and that's DCA. So yeah, so this one we were able to narrow it down to either this one or this one. This one was the better choice, and there was no other choice for this one, so that made our life easy. Okay, now what was said for this to happen? What magical word was said for that to happen? And that was by definition an angle bisector. Blank as a result of the reflexive property. Okay, so what was the reflexive property? That was saying AC was equal to AC. Is that not even? Oh, there. So kind of got cut off. So AC is equal to AC. This would not happen on the test. It would actually say, and probably be backwards, where AC is equal to AC, and why? You would say reflexive property. Okay, so sorry about that. So that's a little thing. That was just like a little typo, so no worries about that. Little typo. Okay, and then the triangle is equal to triangle. Remember, that's what you're trying to prove. So triangle ABC is equal to ADC. How did we know that? That's right there. How did we know that? Travel around the triangle. We have more angles. We have angle. So start here, go in a circle, angle, side, angle. So angle, side, angle, and there's your answer. Angle, side, angle. Boom. All right, let's keep going. All right, and last one on the study guide, thank God. Been going at this forever. All right, so in this one, these two triangles are right triangles, so this is right triangle as well. How do we know that? It was given to us. What was the other given? Wx is equal to yx. Wx is equal to yx. All right, and how we know it's given? Okay, we know xz is equal to xz. I'll put a double on that. How do you know that? That's reflexive. Okay, the two triangles are congruent. How do we know that? All right, when you travel around, you get ass and so you get ass or ass backwards on both of them. When's the only time you can have an ass? Is if you have a leg. So if it's a right triangle, then it's all right. So this is hypotenuse leg. And if we had to go a step further, so what we're trying to prove is WXZ, the angle, is equal to the angle YXZ. So if you ever have to prove something that's not a triangle, then it's always CPCTC. Okay, so the step right before it is saying triangle is equal to triangle, and the last step would be CPCTC. That's it. I hope you guys enjoyed that lesson. Have a great and wonderful day.